Hi, good morning. My name is Manandeep Singh Bhatia. Today, me and my group member Nidhi Mehta, Chaitanya, and Jasvi are going to give a presentation on systematic tree cipher. The learning objective of this lab is to gain a hands-on experience on the concept of secret key encryption. After completion of this assignment, we will begin the experience on encryption algorithm, encryption modes, padding, and initial vector. In this assignment, there are three tasks. The task 1, encryption using different cipher modes. Task 2, encryption mode ECB versus CBC. Task 3, encryption mode corrupted ciphertext. In this lab environment, we will be using OpenSSL. We will be using OpenSSL commands and libraries to complete this assignment. In this slide, we can see there are two screenshots. In the first screenshot, we have used four commands. First command was OpenSSL enc-aes128-cbc-a and plain.txt. We have used this command to encrypt plain.txt to the output plain_cbc.pin. In the second command, we have used OpenSSL again and encrypt plain.txt to the plain_cbc.pin with the -cfp command. In the third command, we have used OFP to encrypt the plain.txt to the output plain_cbc.bin. In the fourth command, we have tried to encrypt peg underscore original.bmp to the output cipher underscore peg underscore aes underscore 128 underscore bmp. So we have tried four different type of encryption and convert those file into specific outputs. Over here in the second screenshot, we can see that we have used the ls command to list all the data or all the folders inside the desktop directory, and we can see over here like plain_cbc.pin and cipher underscore peg underscore aes underscore 128 dot ecb.bmp file. These both files which we have created by the different methods of encryption are present over there. Thank you. Okay, so moving forward, we move to task 2, encryption mode, ECB versus CBC. The file pic original.bmp contains a simple picture, and we will like to encrypt this picture so the people without the encryption key cannot know what is inside the picture. We will encrypt this file using ECB electronic codebook and CBC cipher blockchaining. So So first of all, we will see or we will treat this picture, this encrypted picture as a normal picture and use some viewing software to display it. However, we know that the first 54 bytes of our .bmp file contain the header information about the picture, and we have to set these bytes correctly so that the encrypted can be treated as a legitimate .bmp file. We will replace the header of the encrypted file with that of the original picture, and we can use a GX tool to directly modify the binary files. Below are the screenshot for the same. In first screenshot, we can see that we are not able to see see the picture. However, after using the GX tool, we have replaced the binary. Over here, we can see that we are able to see the screen. So in this slide, we can see there are two screenshots. The first screenshot shows us the error that we are not able to open the image with the normal software. In the second screenshot, we have used GX2 to replace the first 54 bytes of the encrypted file with the first 54 bytes of the original file so that this encrypted picture could be look like legitimate. And after this, we tried to open the file, and over here we can see that we are able to view the picture. Now over here, the second question for the task 2 is display the encrypted picture using any picture viewing software. Can you derive any useful information about the original picture from the encrypted picture? Please explain your observation. So we can see in the screenshot that we are not able to derive any useful information about the original picture from the encrypted one, because the identical plain text blocks are encrypted into identical ciphertext blocks, and the data pattern are not well hidden. Because they are not well hidden, there is no confidentiality is provided. With the CBC encryption, there is more secure mechanism which is used prior to encrypt of each ciphertext block. So that's all from my end.
Hello, ma'am. I will be continuing further after Manan Bhatia. This is Chaitanya. In task 3, we have to answer a few questions related to which we have attached a few screenshots as well. The question is, how much information can you recover by decrypting the corrupted file if the encryption mode is ECB, CBC, CFB, or OFB respectively? Please answer this question before you conduct this task and then find out where your answer is correct or wrong after you finish this task. So as you said, we have answered the question before we perform the task, and we have answered it below as the following, but I'm going to read the questions first. So the second question is explain why, and the third question is what are the implications of these differences. So here is the task that we have performed in the file that we have submitted. So my answer for this would be in ECB mode, simplest one block is affected whilst any hassle in a cipher textual content happens. Moreover, every block is decrypted independently. However, the corrupted little bit of the 30th byte in cipher textual content block, 8 bytes would possibly unfold to all n bits. In plain text block, 8 bytes considering the fact that we do the decryption one block at a time. In CBC mode, there has been an effect on 2 blocks. In CFB mode, there may be hassle in N or R range of blocks. Therefore, the mistake propagation criterion is poorer. In OFB mode, the commence is simplest within inside the key technology system. If the single digit of the 38 byte corrupted, then in simple textual content, that simplest byte or character is corrupted. For the third question, our answer would be ECB mode. For ECB mode, there are numerous motives why the ECB mode of operation is taken into consideration, taken for implementation. During the manner of encryption in equal blocks, the equal blocks are encrypted into equal cipher blocks, which permits for smooth recognition of a repeated message. The attacker can also alternate the order of the encrypted blocks without giving it away to the receiver. Although this mode of operation is meant for encryption of the statistics in the length of a single block and is taken into consideration as a faulty one and abandoned, consequently, it has now no longer be used. For CBC mode, in this mode of operation, by using the initialization vector number 4, whilst any encrypting identical blocks of plain text produces unique outputs for each block. If there may be any mistakes in a block, it will propagate via all of the following blocks. In order to obtain protection, IV out to be a random non-predictable value and the important thing out to be modified earlier than encrypting 2n plus 1 by 2 blocks. With a scale of n bits, the CBC mode of operation is at risk of PA and CCA assaults. In CFB mode, the mode of operation permits the stream encryption. The encryption operation is similar to the decryption, and an error in a block impacts the opposite block. This mode of operation is stable within inside the case of CPA. OFB mode. It additionally allows stream encryption, and the operation of encryption is used for decryption as well. An error in a block does now no longer have an effect on the opposite blocks. The protection of this mode of operation is finished if the encryption key is modified for each 2n by 2 blocks of an encryption, in which n is the range of bits in a block. It does now no longer provide protection from CCA attacks, and consequently, this mode of operation has to be avoided now. Taking under consideration the good and bad sides of the analyzed modes of operation of the AES algorithm, it may be implied that for its right and stable implementation, the CTR mode of operation have to be implemented. Thank you.
Hello, ma'am. Today I'm going to give presentation about our assignment number 6 that we missed, and our group have member Nidhi Mehta, Chaitanya, Manandeep, and Jasveer Singh. That's me. So, first question is define IPSC. The IPSC stands for Internet Protocol Security, and it is a technology that allow secure communication over the internet at IP layer. IPSC can be used to encrypt data between two or more systems on a network. Uh, it helps in security of data exchange of public network. IPSC is a protocol that encrypts IP packets while also authenticating the source of packet. It is commonly used in setting up of the VPNs. What is IPSC Used for? Uh, First, we need to know when IPSC was first developed. IPSC was developed in the late 1990s, and it became the de facto quickly became de facto standard for securing Internet Protocol (IP) traffic by early 2000. Virtual private network, which provide privacy and data integrity in communication between clients and servers, are becoming increasingly popular. IPSC is one of the most widely used security protocol in virtual private network. It is a standardized set of protocols for protecting internet-based transmission and communications that is known as Internet Protocol Security, that's IPSC. In addition to securing data flowing between two hosts, like host to host, the IPSC suite can also be used to secure data flowing between a pair of security gateways, like network to network, or between a security gateway and a host, that is network to host. And one thing more, encapsulating security payload (ESP) and authentication header are the two protocols that comprise IPSC suite. And protocols such as these are in charge of authenticating and encrypting packets that are exchanged between different systems. What are the two phases of IPSC VPN? The two phases of IPSC VPN are IKE phase 1 and IKE phase 2. IKE phase 1 establishes a secure channel between two routers across the internet and negotiate the IPSC SA, that is Security Association, to use for authentication, confidentiality, and integrity. At the end of this phase, there is no data flow yet. The encryption and authentication are done with a symmetric key negotiated through IKE phase 1, called ISAKMP SA or IKE SA. This is handled by Daemon IPSC. The main role of IKE Phase 2 is to establish IPSC security associations. Those assays are used to encrypt authenticate data packets sent between the two endpoints. IKE Phase 2 uses IKE Phase 1's ISAKMP assay as a security channel to negotiate IPSC assays. The security channel is bidirectional. and it can be used to negotiate multiple access at once between two endpoints. When phase 1 establish one bidirectional security association and an optional unidirectional security association. Now that is quick mode assay and that is quick mode assay. The bidirectional ISA KMP assay can handle multiple unidirectional IPSC assays, each on its own. Uh, and now next slide is what is the difference between IPSC and SSL VPN? Uh, IPSC and SSL VPNs are two different types of virtual private networks. They allow you to access your company's network from a remote location, like a office. Uh, because they don't use specialized hardware, they can be easier for user to connect and maintain than IPSC VPN. Both IPSC and SSL VPNs are virtual private networks, or and they allow you to access your company's network from a remote location like a home office. However, they work differently in some important ways. IPSC VPNs have long been used to create secure tunnels between two points across the internet. The tunnel is encrypted using keys generated by external server. The traffic that goes through the tunnel is encrypted. But because the encryption is handled outside of the VPN client itself, it can become a complex process for the user to manage and it can affect their connection speed. Uh, SSL VPNs were created as an alternative to IPSC VPNs that would be more accessible for the user and require less maintenance on their end. SSL VPNs encrypt connections directly from the user's browser. Because SSL VPNs don't use specialized hardware, they can be easier for the user to connect and maintain than IPSC. IPSC's VPNs. But they are also generally less secure because they lack many of the security features of IPSC VPNs. Mm, Next slide is what are the three protocols used in IPSC? Basically, the three protocols are used: the authentication header, encapsulating security payload, and the internet key exchange version. Um, the uh, Authentication header protocol provides connectionless data integrity and data origin authentication for IP datagrams and protect against replay attacks. This protocol works by hashing the packet and sending it over to the receiver end. At the receiver end, the hash is regenerated and compared with the one which is sent. If both hashes match, it means that the packet has not been modified in the transit. If both hashes differ, it means that either the packet has been altered in the transit or a replay attack has occurred. So and then we have encapsulating security payload. It provides confidentiality, data origin authentication, connectionless integrity, and anti-replay service. That is a form of partial sequence integrity, and a limited traffic flow confidentiality. ESP also support encryption only and authentication only configurations. But using encryption without authentication is strongly discouraged because it is very insecure. Then we have IKEV one. That is the Internet Key Exchange version one. Uh, it provides a framework for authentication and a key exchange protocols. It is a part of the IPSC protocol suite that provides a strong authentication and encryption of IP packets. IKEV1 uses UDP port 500 for Internet Key Exchange, but it can also be used with TCP port 500. IKEV1 is composed of two phases, phase 1 and phase 2. IKE is defined in RFC 2409. The main purpose of the phase 1 is to establish a secure authenticated communication channel by using ISA-KMP, that is Oakley protocols. And the main purpose of the phase 2 is to negotiate IPSC Security Association for data protection. Now we have slide 8. Is IPSC symmetric or asymmetric? Well, IPSC uses both symmetric and asymmetric key encryption. This means that each device encrypt the data in packet using the same key. The public key is used to encrypt data, which can only be decrypted with the private key. Uh, IPSC is a security protocol, and as such it has to be provide authentication and secure communication. To accomplish these goals, IPSC uses both symmetric and asymmetric key encryption. When a packet is being sent from one network device to another, for example, a message from a computer to your phone, the sending device encrypts the data using a symmetric key. This means that all the data in the packets are encrypted using the same key. The problem with the symmetric keys is that there's no way for a receiving device to know that the data was actually sent by you or by someone else who may have obtained your encryption key. To solve this problem, IPsec involves asymmetric key encryption in addition to symmetric key encryption when sending packet data between the network devices. In asymmetric encryption, two keys are generated, one public and one private. The public key is used to encrypt data which can only be decrypted with the private key. So when your computer sends a message to your phone and they are both using IPsec, they will use asymmetric encryption when they initialize communication so that the phone can verify that it's truly communicated with your computer. So that's so now we have can IPsec can be hacked. So basically IPsec is a suite of protocols used to ensure the integrity, confidentiality, authenticity of data transmitted over a network. Despite the use of IPsec, your computer security can still be compromised by hacking an unencrypted packet into an attacker system. So IPsec or Internet Security Protocol mm, uh, used to ensure the integrity, authentic, confidentiality, and authenticity of the data transmitted over network. Despite the use of IPsec, however, your computer security can still be compromised, as I told earlier. Uh, IPsec feature is commonly used in virtual private network. There are two main components: authentication header and encapsulating security payload. Uh, AH allows data to authenticate using a hash function. It also ensures that data has not been altered during the transmission. The hash function works by combining a secret key with the data, which provides a unique value called message digest. A recipient will use its own copy of the secret key to verify that the same message digest has been produced for a received data. A hacker can defeat AH by intercepting and modifying an unprotected packet during the transmission, then sending it on its intended recipient undetected. The attacker cannot decrypt the contents of the packet because it is encrypted using ESP. But attacking an unencrypted packet is enough to compromise your system security. ESP provides data integrity and confidentiality protection similar to those offered by AH, but it does so by encrypting packets that contain both the original data and hashed version of data. So it can be hacked. What is the safest VPN protocol? The safest VPN protocol is OpenVPN. This means your connection can be decrypted by anyone else. There are two types of encryption, symmetric and asymmetric. Symmetric encryption divides your data into chunks called blocks and encrypts each individually. Mm, uh, So you might have heard of VPNs if you have ever traveled to a country where internet is censored and you want to get back on Twitter. VPNs can help you access blocked website by making it appear as though you are connecting to the web from other location. While certain VPNs can be slow or unreliable, OpenVPN uses two type of encryption, like I told you, symmetric and asymmetric. Symmetric encryption divides your data into chunks called blocks and encrypts each data individually. Asymmetric encryption encrypts all your data in one go, which is faster than symmetric encryption. So OpenVPN is faster. If you are looking for a trustworthy VPN that will keep your data secure and encrypted at all times, then OpenVPN is the good choice. Uh, why do we use both? Symmetric encryption is slower but secure, while asymmetric encryption is faster but less secure. This makes the combination of both speedier and safer than a single type on its own. So next slide is which UDP port should be open on a firewall to allow traffic from LT, L2TP IPsec based VPN clients to PPTP VPN server on the inside. So the Internet Key Exchange, that is IKE protocol, sets up a security association in IPsec protocol suite to allow traffic on from L2TP IPsec based VPN client to PPTP VPN server side on the inside. You should open UDP port 500 and 4500. To allow traffic from L2TP IPsec based VPN clients to PPTP VPN server on the inside, you should open UDP port 500 and 450 as I mentioned. And the Internet Key Exchange IKE protocol is used to set up a security association in the IPsec protocol suite. The IKE protocol includes phase 1 and phase 2 negotiations. UDP port 500 used for IKE initial negotiation phase, where UDP port 4500 is used for IPsec net transversal. That is NATT. Yeah. Uh, so do we have next? In which IPsec phase are the keys used for data encryption derived? Yeah. The key used for data encryption is derived in IKE, that is Internet Key Exchange phase. This phase is one of the phases of IPsec. The various the other phases are Internet Security Association Key Management Protocol. In order to work properly and securely, IPsec requires two phases. Both peers must agree on a shared security policy, algorithm to use, and cryptographic keys to use. This phase is termed as IKE. This phase occurs in two parts: main mode and aggressive mode. Uh, the main mode consists of three exchanges between peers. The first, the f- the first, the first exchange negotiation IKE policies and create a Diffie-Hellman key exchange, that is DH. The second exchange verifies the identity of the peers and creates the security association, that is SAS, with an authentication header and an encryption key. The third exchange validates that the combination is not vulnerable to a man-in-the-middle attack, and by having each peer send an encrypted nonce that only other peers can decrypt. During aggressive mode, the same information is exchanged as a main mode, but in two messages instead of six. This process is less secure but quicker. Phase 2, IPSC Security Association. This phase is used to determine and agree upon IPsec assay parameters for a secure communication. Uh, now we have explained two methods by which two IPsec routers can authenticate with each other. Mm, IPsec routers can either use pre-shared keys or RSA signature to authenticate with each other. In this case, both routers have a public and a private key pair. A signature is generated using a hash of a message encrypted by a private key of a one router. It can be verified by decrypting it using the public key of the same router. Mm, IPsec router can use either pre-shared key or RSA key signature to authenticate with each other. As I mentioned, with pre-shared keys, the two routers must share a key, typically through a secure channel. The key is then used to encrypt the message being sent between the two routers. Because only someone who has access to the key can decrypt it, the message confirms that both routers have a correct key and are therefore authorized to communicate with each other. And RSA signature are generally using algorithm that provides proof of identity without revealing the secret key used for encryption. In this case, both routers will have a public and a private key pair. The private key is kept secret by each router, while the public key can be made available to anyone. Uh, then we have a signature is generated using a hash of a message encrypted by a private key of one another. It can verify by decrypting it using a public key of the same router. If successful, uh, this provide that the sender of the message is in possession of a private key, then therefore authorized to send messages to the router. I think that's all for the presentation. Thank you, ma'am.